Well, let's make a chi-square goodness of fit template. Here's a spreadsheet. Now, you can go through and this is just the raw labels, set of labels that I'm going to need. And so I thought, well, instead of having you have to watch me painfully type those in, I thought you'd appreciate it if they were here. You can always pause the video, look at the project directions, whatever, in order to fill this out. Now, what I did, I have these all typed in these cells here. These items. I thought it'd be good to put a title on my spreadsheet so I know what the heck it is. And here are the null and alternative hypotheses of a goodness of fit test. I thought it might be nice to make a template that could handle, say, 12 up to 12 columns, and so 12 different data counts for something, and then I have the expected counts and the z-squareds. Now see here, I'm just going z sub 1. That's a subscript, so z sub 1 quantity squared, z sub 2 quantity squared, and so forth up to z12 quantity squared. I went up here and made the A column a little wider to fit all this stuff, and actually highlighted all of these columns at some point. There we go. And did a right click, and I chose a column width, and I went with 0.6 inches because on my screen that kind of made it wide enough to see everything, but narrow enough to see everything at once, and make it kind of big. You don't have to do those things. It just makes it a little easier to see what you're doing. So along those lines, some other things that aren't really statistics in nature, but they're not bad things to know that you can do. For one, might take that and make it bold. Take both of those, make them bold. Probably all my headings here, make those bold. It's a bold day. Make that bold. Now I could probably just highlight this whole thing and make it bold, right? I could probably just go like that and say, okay, make all that stuff bold. I don't think I want to do it for everything in here. Bold, and make that bold. Everything seems to still fit. If not, I could come up here and make that a little wider or something like that. So there we have labels for everything. So here are my hypothesized probabilities, the labels for the 12 of those. I'm going to find sums at the end of these rows to make sure, for instance, the probabilities all add up to 1. I want to make sure that happens. And then I'll want to sum up my observed data counts, because I'll use that to create my expected counts for each of these frequencies. Now, something else I might want to do, again, just to make things prettier, like I could highlight this and I could go looking. In my case, it's under Format and Merge Cells, and I could merge and center, and that makes that title look really nice. Again, you don't have to do that sort of thing, but it's nice to know you can. I could highlight all these. Now in this case, maybe I don't want to center it, so I just say merge cells, and it keeps it left justified. And here, do the same thing. Merge those cells, but don't center. Now, but just because I did do a center, see that I just tell it, oh, I wanted that left justified or centered, and it changes it. But there, that looks a little nicer. And then maybe, all the numbers I'm going to produce and so forth all in here. Maybe I'd like those centered, so I'll click center and things start to look a little nicer. Okay. Now, what I need to input into my goodness of fit are all my hypothesized probabilities. I need to put all those in. Now, to remind me of that, a good thing I can do is I can go up here, I can find the background color stuff and background color, and I can go choose a color. Now, mine seems to default to yellow, so yeah, I kind of like that, and I make that yellow. Observed data counts, I'm going to have to fill all those in as well, and so I'll make that yellow. Now the expected counts, they get calculated, and so here I'm not going to make those yellow, but I'm going to kind of point out to myself that I'm going to be getting numbers in there. And so I find something like a light gray works kind of well. You could use chartreuse, if you wanted to. Similarly, for other things that get calculated, I calculate that, that, sum. I'll calculate the sum here to make sure everything's the same. These values here, I'll also calculate that sum, so I'll get that. Then my test statistic, now actually I'm just going to get that from the sum there, but that's something calculated. I need to figure out my degrees of freedom and then my p-value. And so that's where I'm going to have formulas that end up having stuff show up. Now, instead of getting errors and so forth, maybe it'd be good to put some inputs in here. And so for instance, I could go with something pretty simple, like maybe I'll do 5 of these but not all 12, and I could do 0.1, so there's 10%. I could do 0.15, there's another 15%, 0.15. So now I'm up to 30-40%, maybe 0.20, the 0 probably won't stay, and then that's 60%, and so 0.4. And just to check that I have this right, what I'll do here is I'll say equals the sum, and I'll highlight this whole row to 12. That's M7, and I'll close that off and hit enter, and it adds to 1, which it should. If it doesn't add to 1, I have a problem. Okay, I have to make sure these always add to 1, and so if they don't, I need to look again at what I'm hypothesizing and come up with the right things. Now, I'll put in some data that are maybe slightly different than this. I'll put in 5% there, or 5 out of 100 for my actual counts, and maybe I'll put 20 there, 15 there. So right now I'm at the same number, maybe 25 there and 35 there, and nothing else. And I want that sum. Now the nice part is I could just click here, do a copy, click there, do a paste, and it adds up to 100. Now these numbers add up to whatever they add up to, but I to get some nice numbers to help me out for this first case, I did 100, and they're very similar to the proportions up here, the hypothesized probability, but those are formulas. So now I need to get the expected counts. But here I have to be a little bit fancy because I only want to fill in numbers here if I have numbers up here. Okay, if I don't have numbers up here, I don't want to try to fill in numbers down here. And but I want to make it a template that does things automatically. And so we're going to use a conditional or an if. So I'm going to say equals if. And it comes up and tells me kind of what's going on, and it says I'm going to do a test, and if that test turns out to be true, then I'll do one thing, and then this says the otherwise value, and those are separated by commas. So all I'm going to do is there's a nice spreadsheet command to check if there's a number in that cell, and it's called isNumber. Not bad. So isNumber, and I go up here and I click on that cell and close, and if that is a number, it will come back as true, and then my conditional says, well, if this is true, what do I want to do? Well, I want to create my expected count, and the way I get my expected count is I simply take the number that's here times my total, and that will give me the expected number I would want to see. So I'm going to click up there times that number. Now here I've got to be careful because I just want to copy this down, but as I copy it down the row, this B7 should turn into a C7, and then a D7, and then an E7, and so forth, and that'll happen because I don't have any dollar signs on it. But this N9 never changes places, and so I don't want it to change, and so I need a dollar sign in particular on the N. Now because I'm staying in this row, I don't really need one on the 9, but it's helpful. So I'll go back and put dollar signs there, but that gives me my expected count. And then otherwise, what I want to do is make sure that this thing is just totally blank, and I can do that by putting a double quote with then no space and then another double quote. So 2 double quotes in a row, and that will ensure that just if there's no numbers, nothing shows up. And so I did a conditional with this nifty little spreadsheet thing to check whether I have a number in a cell, and I did. Well, in this first one I should. And so I should get 0.1 times 100, or I should get 10 if I did this right. And I do. And now I can just grab that, drag it down here to fill in to there. And notice, well, it filled in to here. It looks like it didn't fill in there, but if I double click, there's the formula. It's just that it's in the part where it wasn't a number, and so it didn't put anything there. And so I have that all the way to there. I need a sum again, so I'll once again copy and paste there. And I get a sum of 100. That's perfect. I should get whatever the number is here, I should get it there. But I want to check it by doing the sum, not by just copying that number down there. I want to make sure these numbers add up to 100. And they do. And so now we're ready to fill these in. And here, the same idea, right? We want to do our z-squared, where we take our observed number, 5, minus the expected count or number, 10. We'll take 5 minus 10, square it, and then divide by the 10. And that's our z1 squared. And so no big deal, except if, well, let me just do that. I'll just go ahead and do that formula. So I can say equals, and again I need to take that number minus that number, so B9 minus B11, square it, and then divide that whole thing by the expected number, the 10, so in B11, and I hit enter, and I get this nice number 2.5. And I copy that down. Great. But notice what happens when I'm pretty sure I'll get an error when I go here. Yeah. See, that's doing that, and the problem is it doesn't know what to do with it. Now, it might say something if yeah, see, so it's saying value. It's saying that didn't work. And sometimes it'll do those pound signs like that, or hashtag signs, if you will, just because it's trying to put a number that's too big, and you can just widen this out. In this case, it was trying to put a message that was too big, and so I just widened that to see the whole thing. But you see, that's a problem. So we have to go back here and do that whole if thing again. So, whoops. So I can try. Yeah, see, I'm having trouble clicking in there, so I'm just going to start over. I'm going to hit enter. It'll say, oh, I messed something up. I'm going to get rid of it, and so and maybe I'll get rid of all that just so it's not there. And so now I'm going to do my if thing again, and is number. So if is number, I'm going to go check up here again, because certainly, because I could I guess have a 0 in here that I maybe just didn't enter as a 0, and that might be okay. It might still be happy with me and so forth. Might treat it as 0. But I definitely don't want to do anything if I don't have probabilities up here, right? I shouldn't put a 0.0 probability up here. I mean, I should only have non-zero probabilities. So I'm checking that B7 again is a number. If it is, now I go ahead and do my squaring formula. So I take my observed value 5 minus my expected value or count of 10. I square that and divide by the 10, so I click there. So that's what I do if it is a number, and again, if it's not a number, I'll just do the 2 double quotes again, hit enter, hopefully I got it right, and now when I drag this down, I don't get those problem cells there. Okay, so there are my expected numbers. My expected counts are up here. Here are my z-squared numbers, and what I need to do is sum them up. Well, I'm already summing here, so I'll copy that and paste it, and so my chi-square statistic I can just get from there. I can say equals, go click on that cell, hit enter, and I get my 6.04. Now, degrees of freedom, right? That's the number of cells I use here, minus 1. Okay, so in this case it's going to be 4, but I want to do this automatically, and I can do that simply by doing a nifty spreadsheet function called count, because if I count these cells up here, you might think that it's going to give me 12. Okay, but no, it's only going to count the ones that have something in them. And so these have something in them, other than a formula. They have something in them, they have numbers in them, so it's going to count those and get 5, but I need to subtract 1 then, so minus 1. Hit enter, and I should have my 4. So that's a nifty spreadsheet function to help me out. And then finally, for my p-value, I just need to use the chi-square distribution. And so that's equal, and it's chi for chi, and then dist for dist. There might be a chi.dist as well. I'll just use the chi.dist. And it says here I need to give it the number. Well, the number is the chi-square statistic. So I give it that. Then a comma. And I need to give it the degrees of freedom. That's my number 4 right there. So I give it that. And that's all it needs to know. So I close that off and enter that. And I get my p-value that is around 0.2, so 20%. So definitely in this case, I would stick with my null hypothesis. I would fail to reject it. And so I would say that, you know, my best guess is that these observed counts do match in frequency to the expected counts. Okay, they're close enough that I can't really say they're different. And so I fail to reject my null hypothesis. Therefore, each respective observed count matches the corresponding expected count. You know, of course, that's not true, but it's from a statistical point of view. I don't have enough evidence to say it's not true. Okay, and so there's my chi-square goodness of fit template with putting some numbers in to try it out. When you try this yourself, you can put these numbers in and you should get this same p-value. All right, hopefully that was a good take, and we'll see how that goes.